Today we are continuing section 5.4. This time we are solving rational exponent equations. So yesterday we did radical equations. Now we're going to look at rational exponent equations. We're going to start exactly the same way we did yesterday. We need to isolate whatever has the exponent. So in this first one we're isolating the x to the 3/2. In the next one we'll isolate x to the 4/3. Let's see if there's one that looks a little bit more complicated. Not really. But if there was addition or subtraction, you would add or subtract first to get rid of that, then divide, just like we did yesterday. So on this first problem, our first step is going to be to divide by 2. So we have x to the 3/2 equals 125. Once you have the thing with the exponent isolated, we need to raise both sides to the reciprocal of that fraction. So I'm going to write that over here. You may want to add this to your notes. You want to raise both sides to the reciprocal. My daughter has her Polaroid camera out. So if it's x to the 3/2, take 3/2 and flip it, that'd be 2/3. We need to raise both sides to the 2/3. Now the reason that we flip it, from our properties of exponents, when there's parentheses like this, we multiply the exponents. And 3/2 times 2/3 ends up being 6/6, which is 1. So multiplying a fraction by its reciprocal turns it into a 1. Raising both sides to the reciprocal of the exponent eliminates that exponent and makes this just plain x to the first. And then on the right side, we need to evaluate 125 raised to the 2/3. Now, if you remember, this is the same as the third root of 125 raised to the second. So you could use your perfects chart to do this on certain problems, but it's also fairly easy to use your calculator for this. So parentheses are key. Type in 125, close your parentheses. On a scientific calculator, when you use the caret button, I would use parentheses 2 divided by 3, close your parentheses. Just get parentheses around that exponent. That way you're sure that you're raising it to the entire thing. I have found that the ABC button doesn't work very well when you're trying to use it in an exponent. So using parentheses and the division key really does work better. So this is 25. Now the one problem with doing this in your calculator is that you don't really see what root you are doing. By raising both sides to the 2/3, we are taking both sides, we're doing the third root of both sides. If the bottom of the fraction is odd, you're taking an odd root, you don't need to worry about a plus minus symbol. If the bottom of that fraction is even, you're taking an even root of both sides, and then we have to put a plus minus on both sides. So this particular one, the answer is 25. And when the answer is 25, we've got one answer. Because we just did an odd root, we don't really need to check for extraneous solutions. So our answer is 25. On the next one, we start by dividing by 3. 243 divided by 3. Sorry, my daughter's in the background. Once it's isolated, we need to raise both sides to the reciprocal. So take 4/3 and flip it. But the one thing I want you to really watch for is what is the bottom of the fraction that you raise both sides to. This is a 4th root. And anytime we take an even root, we have to consider both positive and negative. So this is really doing the 4th root of 81 and then raising it to the 3rd. The 4th root of 81, according to our perfects chart, and I honestly don't have my perfects chart in front of me, the 4th root of 81 is 3 or negative 3. Negative 3 to the third is negative 27. Positive 3 to the third is positive 27. So if we type in here 81 raised to the parentheses 3/4, we get 27. Really, our answer is positive or negative 27. So what you're really watching for here is the bottom of that fraction. If the bottom of that fraction is even, you're taking the even root on both sides, and that is going to give us two answers, positive 27 and negative 27. And like we learned yesterday, if you get two answers, you really should try checking those answers. So I'm going to check both answers back in the original problem. So I have 3 times positive 27 raised to the 4/3, and that's 243. Then 3 parentheses negative 27 raised to the parentheses 4/3, and that also equals 243. Both answers are fine. We're good to go. The next one, we start by dividing both sides by 2. So we have x to the 1/4 equals 4. We raise both sides to the reciprocal. Take 1/4 and flip it. That's 4 over 1, or just 4. This is one of the easier ones. This fraction does not have a denominator, so we are not taking a root of both sides. We're just raising it to the 4th. So x is 4 raised to the 4th, 256. Oh, it jumped on me. All right, number 5. Number 5, the thing that's raised to an exponent is the entire set of parentheses. So we need to isolate that. If there was something multiplied in front of it, we would divide both sides by that. If there was something added or subtracted after it, we would need to first subtract or add, then divide. But this is isolated, so our next step is to raise both sides to the reciprocal. So we have x plus 6 to the 1/2 equals x. I'm going to raise both sides to the reciprocal of 1/2, which is 2. That gives me x plus 6. Good news here, we don't have to FOIL this because the 2 and the 1/2 cancel each other out, and we just have x plus 6. On the other side, we have x squared. When you have x squared and x, you have to get one side equal to 0 and solve. So I'm going to put a little note here that we have x squared and x. That means that we need to factor. So you want to keep your x squared positive. It's easier to factor if you keep your x squared positive. So although it looks like it would be easier to subtract x squared on both sides, it's actually going to be better to move everything over to the right side. So 0 equals x squared minus x minus 6. We are looking for two numbers that multiply to give us negative 6 and add up to negative 1. I believe that would be 2 and 3. To make it negative 1, the 3 would have to be negative. So this is x plus 2, x minus 3, which means our solutions are negative 2 and positive 3. Red flag, two solutions. We need to check them both. Sorry for all the background noise. So we're checking them back in the original equation, and that's why I rewrote that original equation before squaring both sides so that we could easily see this original equation. And here's your calculator to help you. So I am going to do parentheses, negative 2 plus 6, close my parentheses, raised to the parentheses, 1 divided by 2, 2. Now look, we plugged negative 2 in, and we got 2 on the left side. The right side is supposed to be x. The right side is supposed to be negative 2. That's no good. That's an extraneous solution. Let's plug 3 in. On the left side, 3 plus 6 raised to the 1/2. Oops, that's 1 times 2. Is 3. So I have 3 on the left side. Plug 3 into the right side. The left side and the right side are the same, so that solution works. You might notice that I skipped over number 4. That was unintentional, but not really bad because I was probably intending on skipping number 4 anyway. Trying to make this video a little bit shorter. You may see problems that look like number 4 on your assignment, but they'll look like number 4 but be more like number 5. So you might have something that doesn't have this 2 in front. So it might have something like x plus 3 on the right side. So we're not going to actually do this problem because it's not going to work when I change it this way. I'm just going to take this 2 off of here. If you had something that looked like this, x plus 11 raised to the 1/2 equals x plus 3. To get rid of that 1/2, you would have to raise both sides to the 2. Just like yesterday, remember that if you take something like x plus 3 and square it, that thing means x plus 3 times x plus 3. And make sure that you FOIL, double distribute, whatever it is that you call that, to get that expanded out. So this problem, it would be like x plus 11 equals, and then you'd have x squared plus 3x plus 3x plus 9, and then you'd keep going, getting 0 on one side, factoring and solving. Now this one probably isn't going to work because I took that 2 out of there, which means it's probably not going to factor correctly like it should have anyway. So we're not going to actually finish this one because it's just not really a very good problem. It will be a process more like number 5 where you get 0 on one side and factor and solve. I just wanted you to see that you might see something like x plus 3 on one side, and when you square that, that means multiply that binomial by itself and FOIL it out. Your assignment is 5.4 part 2 on Big Ideas Math. I will get that assigned online in the next few minutes. Oh, hey, let's look at number 6 really quickly. I don't know if I'm going to put a problem like number 6 on the assignment yet. I haven't really thought about it. But what typically happens with number 6 is that some of you freak out when you see word problems because you think word problems are hard. If I give you a word problem, it's probably going to give you an equation and then give you numbers to put into it and then ask you to solve it. So this is, how long should you pour the alloy into the mold to cast a plumb bob with a height of 2 inches? They're saying that the height is 2 inches, 1.5 times the 3rd root of t. All you have to do is solve that equation, which really isn't that hard. Do you notice I didn't read the equation or the word problem at all? All I really figured out was that height is h and t and the time, t is time, t is seconds. That's all you really need to know is what is h, what is t, and then they tell you 2 inches, where do you put that in, and then solve the stinking equation. That's all you have to do on that.